welcome to the mathematics class. Now today this class is for class 9 and we are continuing with our chapter 13, that is rectilinear figures, and we are following the textbook, that is ML Agarwal. We were doing exercise 13.1 and in the previous classes we have done up to question number 17. Now we will start with question number 18. So in this question it is given that in a parallelogram ABCD, so I have drawn a parallelogram ABCD. So AB and CD are parallel and equal to each other, and AD and BC are also parallel and equal to each other since they are opposite sides of the parallelogram. They say in this parallelogram bisector of angle A, means angle A is being bisected. So I have made these signs to show that this angle A is being bisected. Meets DC in E, and this bisector of angle A meets DC at point E. So here I have made a point E and joined AE. So, and it is also given AB is equal to 2AD. This is of more importance, so this I have underlined. AB is given as twice of AD. First point we have to prove that BE bisects angle BE, means we have to join BE. So in the construction we can say, I am writing here only, construction is join BE. In the construction, first of all we will join BE, then we will see what we can do. So joining BE, we have to prove that BE bisects angle B. We have to prove that this angle and this angle are equal. This has to be our proof. It means in the first part we have to prove that angle ABE is equal to angle CBE. Now what is our theory? How we proceed? First we will be explaining or discussing with that. You know that these AB and CD are parallel to each other. Let us say this is angle 1 and this is angle 2. So whatever is angle 2 will be same as this angle. Let us say this is angle 3. It means we can say that angle 2 and angle 3 are equal because they are alternate interior angles, because these two parallel lines and AE will be acting as a transversal, and when a transversal intersects two parallel lines, then alternate interior angles are equal. So angle 2 and 3 are equal. But we know that angle 1 is equal to angle 2. It is given. What is given? That AE bisects angle A, means 1 and 2 are equal. If 1 and 2 are equal and 2 and 3 are equal, it implies that angle 1 is equal to angle 3. It means angle 1 and angle 3 are equal. If angle 1 and angle 3 are equal, it means ADE becomes an isosceles triangle. If ADE becomes an isosceles triangle, so we can say AD is equal to DE, number 1. Now it is given that AB is equal to 2 times of AD. AB is equal to what? CD. We can say AB is equal to CD, and that is given 2 times of AD. Now we have proved that, or we can say that CD can be written as DE plus EC is equal to 2 times of AD, and we have proved that DE is equal to AD. In place of DE we can put AD. AD plus EC is equal to 2 times of AD. So EC will become 2 times of AD minus AD. So only one AD is left. So AD. EC and AD are equal. EC and AD are equal. At the same time, AD is equal to BC because they are opposite sides of parallelogram. This is equal to this as well as this is equal to this. Means we have proved that AD is equal to EC from this, and we have proved that AD is equal to BC. It implies that EC is equal to BD. Now EC and BD are equal. It means whatever is this angle, same as this angle. Let us say this is 3, this is 4, and this is 5, and this is 6. So we can say angle 4 is equal to angle 5 Because we have proved that EC is equal to BD. Because EC and BD are equal, so ECB will become an isosceles triangle, and in isosceles triangle opposite sides are equal, and we know that in an isosceles triangle angles opposite to equal sides are equal, so angle 4 and 5 will be equal. At the same time, angle 4 will be equal to angle 6 because it acts as alternate interior angles. These AB and DC are two parallel lines and they are intersected by transversal. So 4 and 6 will become alternate interior angles. Now 4 is equal to 5, 4 is equal to 6. It implies that angle 5 is equal to angle 6. That proves that angle B is being bisected. This is the theory of the question. This is how we will proceed. Now we'll start writing. How to write? So we'll start with our proof. Now what is our proof? First of all, we can say that angle DAE is equal to angle EAB. It is given. It is given that angle 1 and angle 2 are equal, so DAE and EAB are equal. It is given, you write, or you write that or we can also write that AE bisects angle A. These are the 2 points. Either you write given or you write AE bisects angle A. Then we can say that angle EAB is equal to angle AEB. Reason? This and this are equal. Angle 2 and angle 3 are equal. Why? Because they will act as alternate interior angles. Alternate interior angles. Why? Because AB and CD are parallel. If you want, you can extend your explanation. That is AB parallel CD. If you want to write more, you can even write ABCD is a parallelogram, but that is more than enough. Now EAB and AED are equal. This is equation number 1. This is my equation number 2. So from equation 1 and 2, from equation 1 and 2, we can say that DEA and DAE are equal. Angle DEA is equal to angle DAE. If these two angles are equal, it means that DEA, triangle DEA is isosceles triangle, and therefore we can say that DA is equal to DE. DA and DE are equal. We have proved that DA and DE are equal. Now it is given that AB is equal to 2AD, but AB can be written as CD. So I am writing CD is 2AD, but CD can be written as DE plus EC is equal to 2AD. Now in place of DE, we can put AD or DA, because we have proved that DA is equal to DE. In place of DE, we are writing DA or AD plus EC is equal to 2 times of AD, implies that EC is equal to 2 times of AD minus AD. Again, this AD goes to this side, becomes minus. So what is left? Out of 2 AD, 1 AD is cancelled or substituted or subtracted. So what is left? Only 1 AD is left. It proves or it shows that EC is equal to AD. This is of use, so we will write it in a block. It means that EC and AD are equal. At the same time, we can say that AD is equal to BC. Why? Because it is given what is given? ABCD is a parallelogram, and in a parallelogram opposite sides are parallel and equal, so AD and BC will be equal. So according to this, we can say that implies that EC is equal to BC. Now EC and BC are also equal. It means this part and this part is equal. If EC and BC are equal, it implies that, or we can say angle CEB is equal to angle CBE. We have proved that this angle 4 and angle 5 are equal. At the same time, we can say angle CEB is equal to angle ABE. Why? Because they act as alternate interior angles. It is given, what is given? That AB and CD are parallel, so angle 4 and angle 6 will be equal because they will act as alternate interior angles. Now angle 4 is equal to 5 also, angle 4 is equal to angle 6 also. Here we have proved angle CEB, that was angle 4 is equal to CBE, that is 5. And here again we are proving CEB is equal to ABE. So let this be equation number 3 and let this be equation number 4. So from equation number 3 and 4, what are we going to write? From equation number 3 and 4, we can say that from equation 3 and 4, we can say that angle ABE and angle CBE are equal. CEB is equal to angle ABE. Now CEB and CBE and ABE are equal. It means that BE bisects angle B. That is your proof. This is proved. Now first part is proved. In the second part they say prove that angle AEB is 90 degree. It is very easy. We know that in a parallelogram angle A plus angle B will be 180 degree because they are co-interior angles. This total angle and this total angle is 180 degree. So half of this means if this total is 2x, so this will be x, this will be x, this total is y, 2y, so this will be y and this will be y. Means I am taking let angle A is equal to 2x and angle B is equal to 2y for second part 2. What I have done, I have assumed angle A, this total angle A as 2x and total angle B as 2y. So I have written let angle A is equal to 2x, let angle B is equal to 2y. So we know that A plus B is equal to 180. This total angle and this total angle is equal to 180 because they will act as co-interior or co-planar angles. We know that when parallel lines, two parallel lines intersect are intersected by transversal. So these angles are co-interior angles and they are supplementary or their sum is 180 degree. So according to this theorem or this rule, we can say angle A plus B is equal to 180 degree. So angle EAB is the bisector of angle A and angle EBA is also the bisector of angle B. It means the sum of their half will be equal to half of 180, or we can say by dividing this whole equation by 2, A plus B upon 2 is equal to 180 upon 2, or it can be further written as half of A plus half of angle B is equal to 90 degree. Now, half of A is EAB, angle EAB plus AEB, angle AEB plus angle EBA. EBA is equal to 180 degree. By which property? By angle sum property. By angle sum property. Yeah, okay. By angle sum property we can say this angle plus this angle plus this angle is equal to 180. But EAB is half of A, so it is half of A, means I am writing A by 2 plus angle AEB is as it is plus angle EBA. EBA is half of B, so I am writing B upon 2 is equal to 180. But we know that half of A plus half of B collectively make 90. So in place of these two we can write 90. So 90 plus angle AEB is equal to 180 implies that angle AEB is equal to 180 minus 90, that is 90 degree. That is the proof. This is the proof of this. So we have done with the second part also. Now we move on to the 19th question. 19th question is just the reciprocal or converse of this question. Everything will be same, even the diagram will be same, everything will be same. Only the question what is given here, what has been proved here will be given in the 19th question, and what is given in this question has to be proved in the 19th question. Let's see how to do. Now question number 19, as I told you what was given there, here you have to prove. There it was given in question number 18, it was given that AB is equal to 2AD, but here you have to prove that AB is equal to 2AD. And there it was given that BE, prove that BE bisects angle B, here it is given. I'll read out the question. They say ABCD is a parallelogram, so I have made a parallelogram ABCD. And in this parallelogram, bisectors of angle A and B meet at E. Bisectors of angle A and angle B meet at E, which lies on DC, which E lies on DC. So you have to prove that AB is equal to 2AD. So if this, whatever is this angle, same will be this angle, and these two angles 1, 2, 3. Angle 2 will be, I am writing it in a short. I can say, I am just writing the proof because we have discussed question number 18 first. We can say angle 2 is equal to angle 3. Why? Because they act as alternate interior angles. Now angle 2 and angle 3 are equal. If you want, you can write angle EAB as 2 and AED as 3. Angle 2 and angle 3 are equal. At the same time, angle 1 is equal to angle 2 because it is given. If it is given, so we can say here implies that angle 1 is equal to angle 3. If angle 1 and angle 3 are equal, it means these sides are equal. It means that DA is equal to DE, part 1. We have proved first part. I mean to say half of the question is done. DA is equal to DE. Similarly, in ECB, we can say what 1, 2, 3. Let's say 4, 5 and 6. We can say that angle 4 is equal to angle 6 because they are alternate interior angles, and angle 4 is equal to angle 5 since it is given. So we can say that angle 5 is equal to angle 6, which implies that EC is equal to BC. Now, we know that BC is equal to AD. Reason given, you can say, or you can say opposite sides of parallelogram. We know opposite sides of parallelogram are equal and parallel. Now what we have to prove? AB is equal to 2AD. We know that AB is equal to CD. Why? Again the same reason. Opposite sides of parallelogram. AB is equal to CD. But CD can be written as DE plus EC. This CD can be written as this part DE plus this part EC. We have proved that DE is equal to AD. So in place of DE we can write AD. And in place of EC we can write BC. But we know that BC and AD are equal. From this we can say that BC and AD are equal. So in place of BC we can again write AD. So AD plus AD, this was all CD, CD. CD is equal to 2 times of AD. But we know that AB and CD are equal. So in place of CD, we know that AB and CD are equal. So in place of CD we can write AB. So AB is equal to 2 times of AD. That is the proof. So now we move on to question number 20. Next question is question number 20. In this, what do they say? ABCD is a square and the diagonals intersect each other at O. So I have made a square ABCD. You are always supposed to draw the diagram if diagram is not given. That contains marks. Means you have to write the statement, with the help of the statement draw the diagram, then write down what is given, what you can see in the diagram. Then if any construction required, you will write down the construction, then what is required to prove, and then you will start the proof. But here I have read the statement. According to the statement I have drawn the diagram. I am not writing given and all those, I am only writing what is required to prove. Now what do they say? Square ABCD is there, whose diagonals intersect each other at O. So I have made a point, and this point is O, named as O or labeled as O. Now then they say prove that 3 times angle POB. POB is this angle is equal to AOP. Now for this, to solve this question, if you know the properties of a square, it is very easy, very easy. Number one, first point, we know that the diagonals of a square, they bisect the angles of the square. First we know that diagonals bisect angles of square. Second thing, we know that every angle, each angle of a square is equal to 90 degree. It means if this total angle A is 90 degree, so this angle will become, because diagonals bisect the angles of the square. Number one, we can say angle OAP is equal to 45 degree given. Now I missed one thing. It is given that if a point P is on AB such that AO is equal to AP. If a point P is on AB such that AO is equal to AP, means this part and this part is equal. So what is given? AO is equal to AP is given, and this is of very much use. That is why it is given. Now if these two sides are equal, it means whatever is the value of this, same will be the value of this angle. So we have taken, let angle AOP is equal to angle APO is equal to X degree. Now when these two sides are equal, it means AOP becomes an isosceles triangle. So we can say X plus 45 is equal to 180 degree. Why? Because of angle sum property. Now it means 2 times of x is equal to 180 minus 45 implies that x is equal to 135 upon 2. This is the value of x. This is value of x, or you can say AOP. This AOP we have found. Now we also know third property of a square is that its diagonals bisect each other at right angles. It means we know that diagonals bisect each other at 90 degree or right angles. It means that we can say angle AOB is equal to 90 degree. Given means because we know the property that diagonals bisect each other at 90 degree. So this total angle is 90 degree. Out of this, AOP is x, or you can say AOB can be written as angle AOP plus angle POB is equal to 90 degree. AOP was x, so x plus angle POB is equal to 90 degree. X was 135 upon 2. 135 upon 2 plus angle POB is equal to 90 degree. We can say that angle POB is equal to 90 minus this total portion goes to the other side of the equal to, so it will become minus 135 upon 2. So 90, this is 180 minus 135 upon 2, that becomes 45 upon 2, angle POB. The value of angle POB we are getting 145 upon 2, and angle AOAP, this was angle AOP. Angle AOP we are getting 135 upon 2. If we compare them, so 45 3 times is 135. It means that we can say angle POB times 3 is equal to angle AOP, or we have proved that angle AOP is equal to 3 times of angle POB. That is the proof. So this is proved. Now question number 21, 22 and 23. 3 more questions are left. So I will be taking maybe next 2 questions. 21 is already given in the book. In case you don't understand, then I'll be taking up that also. Otherwise 22 and 23 will be taken up in the next class. Till then, keep on practicing, study hard and stay blessed. Thank you.